So welcome everybody. So in the previous video, I have mentioned about the spin orbit coupling and the applications. So let me continue from where I stopped earlier. So for a complete picture of spin transport, especially in materials with the heavier elements like transition and inner transition, uh, including spin orbit coupling in the DFT calculation is important. So let me brief you how we can set up this calculations. So we need to use band, and then we need to change the task to NEGF and then the periodicity. So we have to enable this unrestricted option to account for spin polarization, which will determine the ground state magnetic configurations. And then we have to switch to the NEGF task. So once the task, everything is set up, we need to do the AMS job run. So after finishing the calculations, let me show you up that what's the exact output. So before that, I need to just brief you what's the other inputs related to spin polarization, which will quantify the degree of spin polarization in the current or transmission, and the local density of state, which analyzes the spin resolved local density of state within the chromium wire to understand how the electronic states contribute to the transport. And also the effect of some external parameters which will investigate the influence of temperature, magnetic configurations, wire thickness, defects and surface effects on spin transport. So let me show you that what will be the standard output. So I have already executed the calculation. So let me show you the spectrum. So this is actually the output of this transmission spin alpha and spin beta in the case of chromium. So sometimes a simplified tight binding model might be used with the NEGF to explore fundamental aspects before going into a fully fledged DFT calculations. So it will ensure self-consistency and convergence for the NEGF calculations, and also the effect of the external parameters, for example, the parallel as well as anti-parallel magnetization of the leads and thickness, other surface effects on spin transport. And also, to summarize, the study of spin transport in a chromium wire with NEGF band is a complex but rewarding endeavor which will be helpful for advanced computational techniques to understand and predict the phenomena in a material with magnetic properties. So before proceeding, let me show you that how we can find this transmission. So this is actually the transmission spectra, transmission plus density of state. So you can see how much is the analysis, and then the current for spin alpha, chromium current spin alpha, and chromium current spin beta, and the total current. So this is actually the complete observation related to NEGF calculation for spin transport in the case of chromium. So thank you. We will see in the next session.